Hello, I'm Laura McSharry, and I'm here to help you ace your scientific investigation skills. So, a little bit about me. I've been a science consultant for a good few years now, and I absolutely love teaching science. So, if you need to get hold of me, you can find some details there. So, scientific investigation skills. So, for the practicals that you do in class, the actual specifics of the practicals, they can ask you up to 10% of your marks on questions like those. However, scientific investigation generally, they'll ask you up to 40% of your paper. So it's really, really sensible to spend a lot of your time making sure you absolutely nail these because they're limited to how many questions they can ask you. So once you understand the questions, you'll be able to answer this on all the required practicals that you do. So what can they ask you? So from your required practicals, they can ask you the very specific skills. So I give an example here of the osmosis practical, where you have chipped potatoes and you put them in different either salt or sugar solutions at different strengths. Now they're going to ask you some specific questions to do with the science behind it. So they're going to ask you about hypertonic, hypotonic and isotonic solutions. And they're going to ask you about osmosis, what it is, why, what can move between, why substances can move or why water can move between membranes and such like. So they're the very specific questions they can ask you. However, they'll ask you very general questions. So what skills, basically they're all based on what skills do you need to make a practical fair or a fair practical. So I'm going to use the example for all of these ideas as is about photosynthesis and light intensity. Are they related? And the first thing that they could ask you is to write a question to investigate. So I've given an example here. Does the light intensity affect the rate of photosynthesis? Now, I've put two parts to that question, and you must put both parts. I've put the independent and the dependent variable. I've put the independent, the thing that we're going to change, which is the light intensity, and the dependent is the rate of photosynthesis, so how fast it's going to happen. So the next thing, you may be asked to write a hypothesis. Now, a hypothesis is what you think is going to happen, but you must explain why using your scientific knowledge. So, if the light was lower intensity, less photosynthesis would occur because, the key word, you must use the because word, the process of photosynthesis requires the energy from light rays to turn water and carbon dioxide into glucose and oxygen. The next thing you could be asked to do is either rearrange some steps in a practical to make them work, or you might be asked to actually write a full practical given a list of equipment. Always write it as a list or a bullet point, and always start with collect the following equipment or set up the following practical using blah, blah, blah. So, and then just step 1, step 2, step 3. It's a much more logical approach and it's clearer for you and you won't get so knotted up in it. Now, when you do a method, you must write a risk assessment, or they could ask you about hazards to do with an experiment separately. Now, I would always advise you to write this table down. So it just takes 3 quick lines. Even if you've got lined paper to write on, doesn't matter. Still write this table down. Write your hazard, how it can be dangerous, and how can you reduce the risk. Now, depending on the marks, if this is a 2-mark question, I would just put 1 hazard down and follow it through the table. If it's 4-mark question, then I would do at least 2 different hazards. So you need to also, in your method, state your dependent, independent and control variables. So we've talked about 2 of them, the thing you change, the thing you keep, the thing you measure, so dependent's what you measure. You need to also write your control variables. You have to say how you're going to make this experiment reliable. Again, this is still in your method. So that's all about how many repeats you're going to do, and make sure to mention you'll take a mean average of results. So for your experiment, you should know how to draw your tables. So when you're doing your practicals in school, make sure you learn how to draw the tables for all the experiments. Again, it'll be worth about 2 marks, usually this question. But if you get it wrong, it's silly to waste those 2 marks. Graphing skills are quite a thing. You do need to know how to do your graphing skills. You need to know where the marks come from. So remember, if you've got a graph that's got numbers and numbers, so the rate of photosynthesis and the light intensity, that they'll both be numbers, then it's going to be a line graph. If you've got numbers and words, like numbers of students with different eye colours are going to be brown or blue, so they're words. That's always going to be a bar graph. That's as a rule of thumb. So the marks for your graph, you get 1 mark for your axes to make sure you write the correct axes. You get 1 mark to make sure your units are there. So if it's seconds or whatever the unit is, depending on what the experiment is. For your plotted points, you get 1 mark, and you can only be up to a millimetre. If you're more than a millimetre out, you will not get the mark. And you finally get the 4th mark for your line of best fit. Remember, a line of best fit can be a straight line or it can be a curved. It doesn't have to go through all your plotted points. So how can you tell if there are anomalous results? In a table and a graph, you need to know. So you're looking for patterns. If you could be given, it's very common to be given a table of results and you have to identify an anomalous result. And then the next part to the question will always be, what will you do with that anomalous result? And you've got 2 options. You can either say repeat the experiment and find the new mean average, or you can say take the results out and find an average without that set of results. So what about the formulas you need to know, the maths behind your practicals? Well, there's quite a few, and I've just mentioned a few that came to my head, but there are quite a few, and you should actually get to know those. But I'm going to do a separate teaching session on the maths behind it. So change in ratios, very common. Ratios themselves, change in rates or change in height or change in growth, anything like that. Ratios, rates of change, averages, as I say, they're just a few. I will do another lesson on that. So interpreting your results, you will be given some data. It could be a graph, it could be a table, and you'll be expected to answer some questions on that. Now, if you're given a table and they ask you, or a graph, it doesn't matter, if they ask you to state what the pattern is, there's usually going to be an increasing pattern and a decreasing pattern, going up and going down. If it's a 2-mark question, you need to state both of those. Now, if it's a 4-mark question, you need to state where it's going up, where it's going down, but you need to use the data to say exactly where it's going up and how it's going up. So you could say between 3 seconds and 5 seconds, the rate of photosynthesis increased because on my graph it shows this at that point and this at that point, showing that trend. And then you have to do the same for the second part of the downward pattern, if there is a downward pattern. So, do these results support the hypothesis? So you have to go back to your hypothesis. What did you say was going to happen? Or it could be as a question written, what did the student say? And then you have to say it. Again, it depends how many marks. If it's worth 1 or 2 marks, it's just simply saying, yes, it does because blah, blah, blah. But if it's worth 4 marks, you're going to have to put data in there. You're going to have to say, yes, it does because at this point it showed that. Or no, it doesn't because my pattern showed this. You can see from this point and that point it showed da, 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 da. So again, depends how many marks it's worth as to how deep you go into that answer. How do you know if your results are repeatable or reproducible? This comes up all the time. And the reason it comes up, we used to call it different words. So they need to know that you know these words now. So repeatable, the results were similar in each test you did. Okay, so it's repeatable. If you did it again, you'd get similar results. Reproducible means the experiment could be performed with other people in a different laboratory using the same method, they would get the same results. So finally, there are only so many questions they can ask you about scientific investigation skills. It's worth looking at past papers and seeing the sorts of questions there and applying them to all the required practicals that you do. So that's it for me. That's a look at scientific investigation skills. I promise it's worth learning and spend 40% of your time learning these skills because it's worth 40% of your marks. Take care from now. Bye-bye.